Greensleeves is releasing its new design and control optimization software for geothermal HVAC applications. This software can work directly with Trane TRACE 700 files to provide rapid design optimization. Greensleeves started developing this technology for its own in-house use 5 years ago and received a first-place global award from ASHRAE for a project designed and controlled by this software. Our software has been used to design and control geothermal HVAC systems in more than 5 million square feet of facilities in the USA and Australia. In the past 2 years, we have focused on converting the software to run on the cloud, making it accessible to ground source heat pump engineers around the world. The software uses advanced mathematics to complete hundreds of simulations in a short period of time, converging to a desired solution. It has several modeling modes: lowest first cost for the geothermal portion, lowest energy consumption, lowest energy and first cost combination, modeling of traditional ASHRAE hybrid controls, and also the design of full-size bore fields. After the design is optimized, the software automatically creates machine language control algorithms that can be downloaded directly into the building automation system. Think about this in a little bit different way. Greensleeves is closing the loop of the design process. Typically, we run manual simulations. With Trane TRACE and the Greensleeves ENtellect solution, it automatically parametrically converges to an optimum configuration. Once that optimum configuration is determined, the machine-to-machine control language is automatically generated. No human translation required, just download to the building automation system. When the system is then turned on, it automatically confirms that performance matches design, measuring actual heating cooling loads to design. And it also measures actual bore field performance, calculating effective thermal conductivity and effective thermal diffusivity. As the software continues to run, it adapts to real building loads, changes in weather, changes in schedules, etc. So it's self-healing, intelligent, and it's constantly doing load and performance analytics. So in essence, the building does get smarter over time, providing the missing feedback loop to stakeholders. Engineers now can determine, were the building loads in line with what they had originally thought? Is the bore field performance in line with what was originally expected? The above approach can allow much smaller geothermal heat exchangers, thereby lowering first costs, yet we can still deliver all the energy savings that ground source heat pump systems are known for. The geothermal market in the US is estimated to be somewhere between 2 to 4% of market penetration, yet market penetration in other countries is much, much higher. The Greensleeves goal is to increase the ground source heat pump market share by managing first cost while delivering the energy savings. This software as a service package constitutes a ground-coupled system design tool that cost-effectively leverages multiple sources of sustainable energy by managing multiple energy sources and sinks, extending the time available to maximize utilization of storage, realizing facility energy cost savings, and the software in itself is very cost-effective. In this schematic, the geothermal control system modulates the GHX or geothermal bore field pump to maximize the heat transfer efficiency. It measures the real-time heat flux to and from the bore field, forecasts future bore field temperatures, and then controls the closed-circuit cooling tower to precondition the bore field as needed. Note that this is significantly different from an ASHRAE hybrid approach, where the closed-circuit cooling tower is cycled on a real-time basis to address hot bore field temperatures. Here's one of the input screens from ENtellect. ENtellect is an intelligent, clean technology software that provides optimized ground source heat exchanger design, reducing the capital outlay in overall heating, ventilation, and air conditioning energy costs for commercial and institutional buildings. Here's an example of a potential project. Note that ENtellect provides comparable energy cost at a significant first cost reduction. This is an Indian reservation medical clinic located in the U.S. Southwest. The original engineer's ASHRAE hybrid design, where he runs the cooling tower in the hot summer months only, required a bore field or an earth-coupled heat exchanger of 320,000 bore feet, whereas the ENtellect design reduces this to 72,000 bore feet. Now the cooling tower size went up, but the first cost, notice the bottom row, went from 3.2 million to 720,000, nearly an 80% reduction. And notice that the HVAC energy costs actually went down with the ENtellect design solution. ENtellect represents a standalone design package. This package allows for an initial building system design that provides a smaller, more cost-effective HVAC solution without the time-consuming multiple software integrations or mastery of many other engineering and energy disciplines. Here's another example of a proposed project in Cleveland, Ohio, a new high school. The engineer's design had a full-size bore field of 157,000 bore feet at a first cost of just under $2.4 million. A traditional ASHRAE hybrid, again, where the cooling tower operates on a real-time basis in the summer as the bore field warms up, reduced the bore field size to 95,000 bore feet, and it required a 260-ton cooling tower. Note that there's about an $8,000 a year additional energy cost associated with compressor energy and cooling tower energy use, but it did knock nearly $1 million out of the first cost. The ENtellect design, however, reduces the bore field even more, uses the same size tower, provides comparable energy cost to the ASHRAE hybrid, yet reduces the first cost to just under $800,000, 2/3 less than the full size and 44% less than the ASHRAE hybrid. Now, if you really wanted to get that additional $8,000 in energy cost savings, note that you'd have to spend the $2.4 million. So if you look at the incremental cost difference from the ENtellect solution to the full-size bore field, that's a 196-year simple payback period. Here's another input screen from ENtellect. Initial cost savings may be derived from smaller system components, such as that reduced geothermal loop field size, smaller capacity boilers, cooling towers, and the reduction and or elimination of these devices, and a combination of these through the use of the design tool. Another example. This is a proposed elementary school in Houston, Texas. The full-size bore field was 82,000 bore feet, the ASHRAE hybrid 58,000 with a 150-ton tower. The ENtellect design cuts this even farther, down to 26,000 bore feet with a 150-ton tower. And notice that the energy costs are very comparable across the board, yet the ENtellect preconditioning adaptive control software provides almost all of the benefit at a 50 to 66 or 68% reduction in first cost. Here's another input screen from ENtellect. Upon completion of the design optimization, ENtellect automatically creates digital control algorithms to be uploaded directly into the building's automation system. This self-learning control software then tracks actual building performance and automatically modifies the control of the ground-coupled heat exchanger. Here's another example. This is a proposed project in India. This is unique because the average annual temperature in this location is in excess of 80 degrees Fahrenheit. Because of those high annual temperatures, the earth temperatures there are also quite high. So a full-size bore field would be more than 200,000 bore feet and more than $2 million in first cost. An ASHRAE hybrid, where the cooling tower operates in the hottest, most humid times of the day, significantly reduces this with a slight energy cost penalty. But look at the ENtellect approach, where we precondition running that cooling tower in the coolest time of the day instead of the hottest time of the day. A significant reduction, 87% less first cost than the full size, 44% less than the ASHRAE hybrid, and actually the lowest energy cost of any of these three solutions. This is another input screen for ENtellect, and this is based on the optimization parameters. Now, using ENtellect, future cost savings will be realized via hybrid design optimizations conducted through later versions or releases, such as the reduction of equipment, the cooling towers, auxiliary boilers, etc. The addition of renewable energy sources, utilization of energy storage devices such as building envelope fabric, soil, and seasonal geothermal storage, and the management of these devices with predictive adaptive control software. ENtellect uses advanced particle swarm optimization to converge to the desired solution. Potential system configurations are generated randomly, then simulated. Those that are closest to an optimum result are then used to generate a new set of configurations. This process continues automatically until convergence. Normally, this would be done by the engineer, manually rerunning simulations until a desired result was reached, potentially taking hours of time. This is a proposed student life center at a university in Northwest Ohio. These results are from the ENtellect simulations and compare a full-size bore field on the left to a much smaller bore field and cooling tower controlled by ENtellect on the right. Note that the full-size bore field without any preconditioning controls has a rise in the mean earth temperature that stabilizes over time. This is nominally a 20-year simulation. Also notice that the entering water temperature stabilizes around 70 degrees with that full-size solution of 32,000 bore feet. Now the ENtellect preconditioning adaptive software cuts the bore field almost in half, does add an 80-ton cooling tower, but notice the mean earth temperature within the first few years stabilizes and actually stabilizes around 60 degrees Fahrenheit, which is about 10 degrees cooler than the 70-degree full-size bore field solution. For this cooling-dominated application, this means that this building will actually have lower energy consumption with the Greensleeves ENtellect preconditioning solution and the cooling tower than a full-size bore field on its own. Trane added the Greensleeves Geothermal report to version 6.3.1.1 of TRACE 700 in September 2014. This feature allows TRACE to automatically create the needed input for the ENtellect design and control optimization software. To generate this report, you have to do a few things inside TRACE. First, in the plant section, you must have reject condenser heat set to the ground loop. Then, press the controls button near the right-hand side of the screen. In that screen that pops up, press the cooling plant and geothermal controls. Then, in the geothermal loop section, select either the International Ground Source Heat Pump Association library model, or in the library you can create your own custom schedule for ground loop water temperatures month by month. Note that if you don't do this step, you won't be able to see the regular Trane TRACE 700 geothermal report. However, it will still generate the Greensleeves.gs file. With TRACE in the Project Navigator mode, press Ctrl-Alt-T, opening a new window. Double-click on the T700 SimSettings.exe file, and then check the box for the Greensleeves Geothermal report in the lower right-hand corner. Click OK to save this setting. Now you're ready to recalculate and automatically generate that .gs file. When you run TRACE then, it will generate a .gs file in the format with the extension .gs for Greensleeves, and the number that follows will be your Trane TRACE alternate. In this case, this is for alternate 1 of the simulation. Greensleeves has created an Excel spreadsheet that's available to TRACE 700 users for free by request. It includes a trace.gs file procedure summary, how to set up the geothermal entering water temperature schedule in TRACE 700 in the library function, how to use Trane Chiller Plan Analyzer for a very fast geothermal analysis in the conceptual design phase of a project, how to use the TRACE 700 new file wizard for a fast geothermal analysis in the conceptual, schematic, and design development phases. And finally, links for downloading 8760 hour weather files that are needed for the Greensleeves simulation software. To request a copy of the above, please email us. This email address is also in the information section below. We'll be happy to do that file. We know your time's valuable, and we appreciate the time you've taken to watch this video. If you'd like to learn more about the ENtellect design software, you can contact either your local multi-stack HVAC equipment representative or Bob Braam, Senior Vice President of Sales at Greensleeves. Again, thank you for taking the time, and we wish you much success in your geothermal and ground source heat pump adventures.